Well, hi, I'm Stephen Neshiba, and I'm here to help you out with some ideas regarding moles and molar masses and average atomic masses. This is largely, regarding Chapter 2 in your textbook. So this is just a few basic ideas, really. There's my depiction of a proton, or maybe a neutron, or maybe just a hydrogen atom. And one important idea here is that a proton or neutron or hydrogen atom weighs about 1 AMU, and the AMU stands for atomic mass unit. So that's a very tiny unit, because protons are tiny. But the same idea just extends to a slightly larger atom. So this is the nuclide symbol for chlorine-35, and the 35 means that we're thinking about an atom of chlorine that has 17 protons, that's what makes it chlorine, and 18 neutrons, which adds up to 35. So we say that the atomic mass of chlorine-35 is 35 AMUs. There's another isotope of chlorine, it's chlorine-37. Chlorine-37 has, of course, 17 protons, because that's what makes it chlorine, but it has 2 more neutrons, and so it has, one atom of chlorine-37 weighs 37 AMUs. Okay? So, what's the mixture on Earth? If somebody hands you a bag full of chlorine atoms, what's the whole, what's the average chlorine atom going to weigh? Well, turns out that on Earth, a typical, the chlorine occurs with 76% of the chlorine atoms are chlorine-35 and 24% are chlorine-37. So you can say, well, the average atomic mass, the average, would be, it's going to be closer to chlorine-35 than it is to chlorine-37. And since it's 76% 35, you can probably pretty well guess it's going to be, something close to 35.5 AMUs. That's the average. Okay? So that's that idea. Now, the second idea here is what happens when we scale up to large numbers of atoms or molecules. So just by analogy, I'm just going to say everybody knows that a dozen means 12, 12 eggs, 12 atoms, whatever you like. A mole is just like that, but it's a bigger number. A mole is 6.02 times 10 to the 23rd atoms or eggs or whatever you're working with. And here's a really key idea. 1 mole of chlorine-35 atoms, that many chlorine-35 atoms, turns out to weigh 35 grams. 35 grams, and it's a little bit more than this eraser. Okay? Therefore, 1 mole of chlorine-37 weighs 37 grams. 1 mole of hydrogen, and I'm drawing the nuclide symbol for hydrogen here. It's just a proton with its electron, weighs 1 gram. Okay, so you can kind of just easily connect the mass, the atomic mass in AMUs to what's called the molar mass in grams per mole. Okay, so I'm just really repeating this here, but we would use this symbol M, capital M, for the molar mass. The molar mass of chlorine-35 is obviously 35, and the units are grams per mole. The molar mass of chlorine-37, obviously 37 grams per mole. And the molar mass of hydrogen atoms is 1 gram per mole, and so on.